lesson 5 for year 13 physics on Kirchhoff's laws. Now, Kirchhoff, he had two laws, and Kirchhoff's laws are actually used to solve problems for parallel circuits where there's more than one energy source. Now, the two laws are actually based on conservation. So one of them is the current law, and because current is a flow of charge, this is also called the conservation of charge. So a junction is wherever you have more than one wire meeting. So the total current entering a junction is equal to the total current leaving the junction. And the second law is the voltage law, and because voltage is to do with the amount of energy carried by charge, it's also the conservation of energy. And according to Kirchhoff's voltage law, the sum of the voltages around a closed loop is equal to 0. Now, Kirchhoff's law do not apply if the loop is not closed, like if you have an open switch. I will solve a problem using Kirchhoff's laws so you know how to go about that. Okay, so this question is to do with finding what is the three currents going through these multiple branches. So what I've done is I've color-coded. So you have your voltage sources, there are 3 of them, and there's resistors, there are 2 resistors here. So looking at the current law, if you look at that junction, the total current entering your junction is I2, and the leaving the junction is I1 and I3, so I get I1 plus I3 equals I2. Now, looking at the loops, I've just labeled them, given some letters to it. So looking at the loop A, B, E, F, A, and then if I decide to go in the clockwise direction, so if I go from here to here, it's going against the current, so charges have more energy before entering rather than after leaving. So this is the resistor. So resistance times current is voltage. So 2 times I1 plus 6 volts, and then there's nothing here, and now you're coming out of the negative end of this battery, so it's minus 20, and now there's nothing at all, so it's 0. So that's how I get this equation, and then I solve for I1 and I get 7 amps. And then if I look at this loop here, I get and again I could choose to go clockwise or anti-clockwise. In this case I have gone anti-clockwise, so I go 4 times I3, it's going against the current, and there's more energy here. Okay, and then I'm coming out of the positive, so it's plus 6, and then I'm coming out of the negative end of this, so it's minus 20 equals 0, and you solve for I3, you get 3.5 amps, and then I use the initial equation here, and I get the value for I2. And here's another one if you just want to look at it and reason out for yourself. Here's another question.